In this video, you are going to learn about percent composition and how to calculate it. So percent composition is the percentage by mass of each element in a compound. And so in this first example, you are asked to find the percent composition by mass of each element in 1 mole of sodium oxide. The formula for that is Na2O. So we'll actually have two answers here. We're going to have the percentage of Na and then the percentage of oxygen. Those will be our two answers. So I've given you two equations here to help you solve this. So in the numerator, we will have the mass of Na and then divided by the molar mass of the whole compound. So in this compound, you can see that there are 2 atoms of sodium. So in the numerator, we're going to have 2 multiplied by the mass of 1 sodium atom. So the 1 sodium atom has a molar mass of 22.990, divided by the molar mass of the whole compound, which is 61.979. And then we'll multiply that by 100 to get 74.186%. And then the other part of the problem, we'll have the mass of oxygen in the numerator. We can see that in this formula we only have 1 mole of oxygen. Molar mass of 1 is 15.999 divided by molar mass of the whole thing, and then again multiplied by 100. So we'll get 25.814%. A good way to check your answer on these problems is to add up the percentages. They should add up to 100%. We'll look at another example. This time we have the compound copper 2 chloride. So we have to think back to our bonding unit to figure out, first of all, what that formula is. So copper 2, that means that copper in this compound has a charge of +2. And then chlorine is Cl with a -1 charge. So crisscross those charges, and we get the compound CuCl2. So, again, we'll have two answers in this problem. First, I'll have the mass of copper in the numerator here. I just have 1 copper atom in this formula. So the molar mass of 1 of those is 63.546 divided by the molar mass of the compound, which is 134. And then multiplied by 100, and you get 47.263% copper. That's answer number 1. You also need to find the percentage of chlorine in this compound. And so we'll have the mass of chlorine in the numerator. Notice that in this compound there's 2 of them. And so that means that we'll need to multiply the molar mass of 1 chlorine atom by 2. Divided by the molar mass of the compound, 134.452, and then multiplied by 100. So you'll get 52.737% chlorine.